Hi everyone, this is Course 3, Lesson 19, Polygons. So what is a polygon? Well, a polygon is made of segments, so it has straight sides. It is closed, which means the sides meet, there are no open edges, and it's 2D, not 3D. So it's a flat shape, it's two-dimensional, not three-dimensional. And what do I mean by all of that? Well, look below here. These two on this side are they are polygons. So these are polygons, and you can see that this rectangular shape here, which may be a square, I don't know, is made of segments, so the edges are straight, the sides are straight, and they meet. Okay, so this segment meets up with another segment, so it's closed, and it is flat. It's two-dimensional. This shape down here, well, it has a way in, right? It has a little notch out, but the edges are still segments. This segment, that segment, this segment. Okay? Do you see how even though it has a little notch out, it still is very much connected? All those sides are connected to the next one. On the right side, we have examples of items that are not polygons. Okay. This one right here is a cube, and this is 3D. So it is not a polygon because it's three-dimensional. This one, this yellow circle, it's curved, right? So this is not segments. So that's why this is not a polygon. And this guy here, while his edges, his sides are segments and they are connected, see how we have this opening right there? That is not closed. In order for that to be a polygon, we would have to have a segment that closes that up. Okay, so that's the difference between a polygon on the left and not polygons on the right. So what are we going to do with them? Well, this slide here has a lot of information that you need to write down. And if you can't get this all from left to right, that's fine. Write, 2 or 3 across and then do the next ones. But you can classify polygons by the number of sides. Okay, so if we have 3 sides, it's a triangle. 4 sides is a quadrilateral. 5 sides is a pentagon. 6 sides is a hexagon. 7 sides, heptagon. 8 sides, octagon. Now this one here, this octagon, doesn't need to be filled in. It's just that I had a picture that was filled in, and so that's the one that I used. Continuing our pattern here, we went through 8, so we have 9 sides, nonagon, 10 sides, decagon, 11 sides, undecagon, and 12 sides, dodecagon. After that, we just name the number of sides and then put gon with it. So it's a 13-gon, a 14-gon, and so on. So if we had 58 sides on a polygon, we would call it a 58-gon. Okay? Also keep in mind that while the pentagon and the hexagon look like ones that maybe you've seen before, this heptagon, we could have also done that with the hexagon or the pentagon. As long as we have 5 or 6 sides and they all connect to the one next to it, it can look as awkward as this heptagon, and it's still a polygon. Now, this right here is pretty important. Hopefully you remember this from last year, but a regular polygon is a polygon with all sides congruent and all angles congruent. Okay, so when you hear the word regular polygon, it means something special. All sides and all angles are congruent. And what does congruent mean? Congruent means they have the same size and the same shape. So they'd be equal, like the angles would be equal measurement, or the sides would have an equal length. So I have 2 examples here. One, a triangle that is a regular polygon. I know it's a triangle because it has 3 sides, and it's regular because each of the sides are 5 and then they have these marks here, that's also going to indicate that they're the same. One mark means, oh, match those one marks up and they are all the same size. Also, we have these angles that are marked. They have the angle curve mark, and then they have two lines to indicate that those are congruent as well. So we could have had sides that were marked with one line, or we could have sides that are marked with two lines. You just match up the ones that look the same with their geometry, the tick marks, and that indicates whether they're the same or not. And we'll go over that a little bit more in lesson 20. This irregular polygon, still a triangle, 3 sides, but notice that the side lengths are not all the same. In order for it to be regular polygon, all sides must be congruent. So that's why this one is not regular. Okay. Okay, so how can we identify polygons by the vertex letters? Well, the vertex is the point where two sides of a polygon meet. So side A, segment AB and segment BC meet at vertex B. It forms an angle there, so that's the vertex, or vertex C or D or E or A. And in order to identify by vertex letters, we start at any vertex and list them in order, either clockwise or counterclockwise. So clockwise goes around like the clock, and counterclockwise goes the other direction. If I start at A and go clockwise, I would name this polygon, and hopefully you realize that there are 5 sides, so it's a pentagon. So we're going to start with A and go clockwise, A, B, C, D, E. Or I could start at A and go counterclockwise, A, E, D, C, B. Or I could start at C, C, D, E, A, B. Or go the other direction, C, B, A, E, D. Okay, and I could start at D or E or B and do the same thing. So it's just kind of a map that tells you that we have 5 sides, and they go in the order of A, B, C, D, E. Okay? So I want you to try this. Sketch a hexagon, LMNOPQ. While you're working that out, pause the video. I'll open this little curtain over here, and you'll see the result when you press play. Okay, so you should have a hexagon, 6 sides, that starts at L and goes LMNOPQ. Okay, not randomly just put down there. Just pick any starting vertex and label them L through Q clockwise or counterclockwise, and that would be appropriate way to name or identify that hexagon. One last thing in this lesson, we have similar and congruent, and we already talked about congruent a little bit. But similar figures have the same shape but can be a different size. Okay? They don't have to be a different size, but they can be. And what we're talking about there are pictures that you enlarge or you shrink. Okay? This is important. An enlargement is called a dilation. So when the shape gets larger, it becomes a dilation. So if I ask you, is it a dilation, yes or no, you have to say whether the shape got larger or not. So if we look at, let's see, I'll just call this triangle 1 and triangle 2. Okay, triangle 1 and triangle 2 look similar. Okay, they look almost identical. Like if we shrunk triangle 1, it would look like triangle 2. Likewise, if we went from triangle 2 to triangle 1, triangle 1 is a dilation of triangle 2, and I can show you that here. If I take this triangle and make it larger, we can almost put it on top of there, right? If I go just a little larger, there we go. Okay, so that's a dilation. I made the triangle, I just scaled it up from this triangle 2 to 1, and that made 1. So they're similar. Okay, this triangle over here, we'll call this triangle 3. it is not similar to either triangle 1 or 2. Notice how the sides almost all look to be the same length, where these triangles, clearly one side is shorter than the other. Okay, so you kind of have to think, could I enlarge or could I shrink? If you can and get the same figure, then they're similar. Now, congruent figures have the same shape and are the same size. So it's something that you would copy. So you can tell that these two are the same, and you can clearly tell that this triangle over here is not the same as those. However, I just want to point out that if this triangle were like that, these two are also congruent. Same with the triangles up here with similar triangles. The orientation, or the direction that it is on the paper, can be whatever it is, as long as when you rotate them, you would get back to what you're looking at in, or your reference triangle. If you can rotate one triangle and it looks like the other one, then you may have similar or congruent figures. The symbols, similar and congruent, have symbols. Similar is going to look like this, and congruent is going to look like this with an equal sign under it. Okay, so you'll have problems that tell you that triangle ABC is similar to triangle XYZ, but they'll use this symbol. So you need to know that that symbol means similar and that this symbol means congruent. Now, if you look at the two, this is the symbol for similar with equals. That's congruent. So all congruent figures are automatically similar. Okay? So these are also similar. And you might be asked a question about that. If they're congruent, they're automatically similar, but it doesn't work the other way around. Okay? So that's an introduction into polygons. Actually, it's a little bit of a review from last year, so hopefully you remember some of that. And if you have any specific questions, please let me know. Otherwise, we'll discuss in class.